Problem 4.12. Let user be a sequence of all positive integers containing no zeros in their decimal expression. Okay, so user from n equals 1 to infinity is the sequence of 1, 2, 3, 4, 5, blah, 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 9, then not 10, and we have 11, 12, blah, 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 19, not 20, and then we have 21, blah, 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 29, not 30, and so on, right? And we have 99, 100, but then we do not have 101, the next one will be 111, right? 119, and so on and so forth, okay? So this is the sequence. If you have a 0 in the decimal expression, you don't have the number in this sequence, right? Now the first item for this problem is to prove that this series, the sum from n equals 1 to infinity of 1 over u sub n, so the terms, all the terms in this set, is smaller than 90, which is weird. And the hint says to group all terms u sub n with the same number of decimal digits. Okay, so the decimal digits can be, so k1, k2 digits, k3 digits, k4, and so on. And so for 1 digit we have 1 up to 9, right? For 2 digits we have 11, 19, 21, and so on, and up until 99, right? For 3 digits we have 100 and 11, and then 190 up until 99, right? And for 4 digits we have 1, 1, 1, 1, and then up to 9999, right? Okay, so you can see the idea. Now we can see that all of these terms, right, are greater than 1 actually. So this is greater than 1. Okay, all of these terms are greater than 10. All of these terms are greater than 100. All of these terms are greater than 1,000. Okay, so that means that 1 over n, the terms, all of these terms, 1 over 1 over 1 here, these are, but if we divide, these are u sub n, right? U sub n will be smaller than 1, and here 1 over 1 u sub n are smaller than 1/10, and u sub n are smaller than 1/100th, and so on and so forth. Okay, and you can see, so for k equals 1, this is equal to 1 over 10 to the k minus 1. This is equal to 1 over 10 to the k minus 1, because k is equal to, okay, right? So k to the 0, k to the 1, k to the 2, right? Or let's sorry. This is maybe confusing. This is 10 to the 1 minus 1. This is k to the 10 to the 2 minus 1, 10 to the 3 minus 1. So in general, if you have the set of digits with set of the 1 over these integers with no zeros, they are smaller than each of them, they're smaller than 1 over, let's call them u sub n k, right? So u sub n 1 with 1 digit, with 2 digits, with 3 digits, right? These are smaller than 1 over 10 to the k minus 1, right? Now the sum of these, right, all of these numbers, okay, if you sum this, okay, how many of these are then? Well, for here we have 9, right? For here we have actually 81, right? And so the idea is 9 in the first, so 9 terms for 10, 9 terms for 20, 9 terms for 30, and so 9 times for 9 decades in a sense, right? And so this is 9 squared, okay? And in general, there are 9 to the k terms with k digits that belong to this set, okay? The combinatoric argument is that each number with k digits, okay, k digits here. If you belong to this set, this can take any value except 0, okay? So either 1, 2, 3, 4, so there are 9 possibilities, and then there are 9 possibilities in these, 9 possibilities, 9 possibilities, okay? So there are 9 to the 5 numbers with 5 digits, okay? So this is the sum of this is like the sum of 9 to the k terms. All of them are smaller than 1 over 10 to the k minus 1, which is equal to 9 to the k over 10 to the k minus 1, right? Okay, so the sum of all of this, because there are 9 to the k terms in this sum, and all of them are smaller than this, okay? So the sum is smaller than 9 to the k times this, okay? And now we can sum this, we can do this sum for every digit from k equals 1 to infinity, okay? So the sum from n equals 1 to infinity of 1 over u sub n is equal to the sum from k equals 1 to infinity of, well, it's not equal, sorry, it's smaller than, okay, is smaller than 9 to the k over 10 to the k minus 1, right? Because this is, we're summing, if you want, every term, we divided them in digits, and now we sum over all digits, right? Now this sum is equal to, and then we have, let's see, we can multiply and divide by 10, so this is 10, and equal to k equals 1 over to infinity over times 9 over 10 to the k, right? And now this is a geometric series, right? We know how to compute this. This is 10, and then because it starts at 1, the first element would be 9 over 10, and then we have 1 minus 9 over 10. 1 minus 9 over 10 is 1/10, so this multiplies 10 here, so we have 100 divided by 10, 10 times 9, 90. Okay, so this sum is smaller than 90, which is what we wanted to prove, okay? Now, part B says, what can you say about the series sum from n equals 1 to infinity of 1 over Wn, where Wn is the sequence of all positive integers containing at least 1 0, right? So it's 10, and then 100, and then 101, 102, 103, 109, and then you go to 1,000, and then 1,001 up until 1,000 and it is 099, right? And so on and so forth, right? No, sorry, yeah, this is also 110, yes, and here it's 110, okay, like this, okay? So what can we say about this sum, the sum of the inverses of this one? Okay, so we have the harmonic series, right, is the sum of the inverse of all the natural numbers, and we can divide it in these two sums, right? Because either you're a natural number with a 0 in it, or you're a natural number with no zeros in it, which is the one that we calculated. Now we know that this is infinity, this is divergent, but we know that this is smaller than 90, so this converges to a finite value. So that means that this series, the series of the inverse of the positive integers containing at least 1 0 in the decimal expression, is also divergent. Which, I mean, if you ask me, it's a very interesting result, because I would say, you know, at first sight, that this sequence contains many more numbers, right, than this one. But in fact, the sum of 1 over this is actually divergent, while this isn't, which is amazing, okay? And the idea is that, you know, as you get to very large n, the probability that a number, you know, any number, whatever, with a lot of digits, right, the probability that it doesn't have a 0 goes to 0, right? Okay, so at least, you know, there may be more numbers that has zeros that numbers with no zeros. Okay, so the probability that it only has numbers between 1 and 9 is negligible. Okay, when n is very large. Okay, and that's the end of the